All right. Hello and welcome everyone. So welcome back to this amazing platform of Tutee Learning. We are live again on this amazing platform, right? So please let me know. Am I audible to all of you? Yeah, great. So I'm audible to all of you and I'm visible as well, right? So welcome back to this amazing session. And today in this particular live session, we are going to learn about another very important topic that is going to be definite integral, right? So our topic of discussion from today's class and onwards is going to be on definite integral, right? तो अगर आप इस चैनल पे नया हो तो प्लीज चैनल को सब्सक्राइब करो और इस वीडियो को लाइक करो एंड इस वीडियो को अपने दोस्तों के साथ भी शेयर करो ओके सो प्लीज शेयर दिस वीडियो as much as possible with your friends and your relatives as well, okay, and also the students whom you think that they actually need these particular lectures, okay. So we are going to start a definite integral from today's session, okay, and onwards. So ओके सो अगर आपने अभी तक चैनल का सेशंस आपने देखा नहीं होगा तो प्लीज एक बार चैनल को सब्सक्राइब कर लो और चैनल पे जाके आप लाइव टैब के अंदर प्लेलिस्ट या फिर प्लेलिस्ट के अंदर जाके आप इंटीग्रल्स प्लेलिस्ट का चेकआउट कर सकते हो ओके सो प्लीज वॉच द प्रीवियस क्लास बिफोर यू कम टू वॉच दिस पर्टिकुलर सेशन ऑफ डेफिनेट इंटीग्रल ओके नाउ डेफिनेट इंटीग्रल एक काफी इंपॉर्टेंट टॉपिक है जेई मेंस और जेई एडवांस दोनों एग्जाम्स के लिए काफी इंपॉर्टेंट है तो आज का जो सेशन होने वाला है वो काफी ज्यादा इंट्रोडक्टरी सेशन होने वाला है और काफी ज्यादा क्वेश्चंस प्रैक्टिस करेंगे कि हम अगर indefinite integral सॉल्व करना आ गया so only thing you have to put the limits and then to solve for the question, right? And there the most important part of definite integral is basically solving the properties, right? So when we discuss our properties you have to be very careful that how I am using the properties to solve different sets of questions, okay, and we will try to solve as many as number of questions as possible, and also along with that we'll see the previous year JEE mains and JEE advanced questions along with the sessions as well, okay. So please stay tuned for the sessions, okay, and let's get started, okay. And we have already started our live batches, and for checking out the live batches or online tuition, you can always find the information given in the description box of this particular live video. So let's get started, right? So if I talk about definite integral, what actually comes to your mind? Okay. So when I talk about definite integral, so if I talk about definite integral, the very first thing that will come to your mind that what is definite integral, right? So let us say I have a function, let us say f is a function, okay. Let us say f is a function, okay. Let us say I have f is a function of x, okay. F is a function of x which is defined on the closed interval, okay, which is defined on the closed interval, sorry, it should be closed interval, which is defined in the closed interval, okay. Let us say it is defined in the closed interval a to b, okay. It is defined in the closed interval a to b, right? And let us say I have another function phi is another function, okay, phi such that I have phi dash of x or derivative of phi is equals to f of x, okay, such that the derivative of phi is equals to simply equals to the function f of x on the closed interval a to b, okay. So we have, and it is valid for all x belongs to the domain, okay, for all x belonging to the domain of the function, right? So if we have this definition, we know from integration is basically the reverse of differentiation or the antiderivative, right? So therefore, I can define a special integral like integral within the limit. So this is basically called as integral within the limit from lower limit a to upper limit b, right? So for this function f of x dx, and it is equals to, it is given as phi of x plus some constant c for interval a to b, right? And that can be given as phi of b minus phi of a, right? So this is the basic definition of definite integral. This is the basic definition of definite integral, right? Now the most amount of time is gonna be taking, that's basically going to be the solution of the or the evaluation of the integral, right? So you have already seen how to evaluate integrals in the previous chapter of indefinite integrals. So we are going to use those types of questions and we're going to see how we can evaluate this integral and just putting the limits, what is the final solution of the definite integral, right? Now if I talk about what does definite integral geometrically means, or what is the actual implication of definite integral, then please wait. We are going to discuss about another very important topic, that is how do we evaluate and what is the geometrical interpretation of that definite integral. I'm going to talk about that in this particular lecture, but in the later half of it. So please wait for it. Okay. Well, so whenever you get any integral, whenever you get any definite integral of this particular form, okay, so whenever you get a definite integral of this particular form, the steps to evaluate this integral is, first of all, evaluate the result for this integral, and then ultimately to put the values of the lower limit and the upper limit and then subtract it. That's it. Okay. So let us take some few questions to basically solidate our understanding of this particular topic. Okay. So let's say I have some example questions. Let's say I have a given integral which is basically integration from 0 to 1, and the integral is given as 1 upon 3 plus 4x dx, right? Now, how do we solve this question, right? So first and foremost step to see in this question is that you don't have to worry about the limit in the first of case. Firstly, try to find the solution of this integral. Try to find the solution of this integral. So if I solve this integral, the integral result is very easy. So it is going to be equals to natural log of mod of 3 plus 4x, right? And then whole divided by 4, whole divided by 4 within the limit 0 to 1. So now our task is basically to put in the limit. So 1 upon 4 is a constant. So if I put x equals to 1, then your solution is going to be natural log of 7 minus, if I put x equal to 0, it's going to be natural log of 3, right? And we know that the property of logarithm, we can write this result as 1 upon 4 natural log of 7 upon 3. So that is going to be the result of this definite integral. I hope this question is clear, right? So these are very simple question to start with. So I hope this method of evaluation is clear to all of you, right? Now let's move to some bit of a interesting question. Okay, let's say I have a given integral to solve. Okay, the integral is basically given within the limit 0 to pi by 2, and the result is sine to the power 4x. Okay, now why I'm taking this example right now? Because it's a very special form of integral for 0 to pi by 2, whenever we have sine or cos and to the raised to the power of any integral higher power. So that kind of question is always, we will be learning about a very specialized method that is called as the Wallis formula. Okay, but for the time being, let's not be getting into that Wallis formula thing. I will talk about the recursion relation, and then I will talk about the Wallis formula, right? So let's see how we can solve this question at this present moment, right? So in order to solve questions of this kind of form, where you have sine square or sine to the power 4 or any higher power, we generally use the trigonometric ratios, right? So, or trigonometric identities, right? So if you know the multiple angle formula, cos of 2x, cos of 2x is basically given as 1 minus 2 times of sine square x, 1 minus 2 times of sine square x. So from here I can write sine square x as 1 minus cos 2x whole divided by 2. So I can write sine square x as 1 minus cos 2x whole divided by 2. Right. So if I use that relation over here, I can simplify this integral as, so I can write sine to the power 4 as sine square x whole square of it, right? So sine square x will be given as 1 minus cos 2x and whole square of it, and this 1 upon 2 whole square will come out as 1 upon 4 over here, and then we have dx over here, right? Now we have to just evaluate this result by, so if we evaluate this result, so 1 upon 4 will be taken out, and we can expand this expansion. So it will be 1 plus cos square 2x minus 2 times of cos of 2x, 2 times of cos of 2x. Okay, so now I will just integrate this result, and then I will put the value of the limits to get to the solution, right? So if I just integrate the result over here, now one more thing is that how will I evaluate this cos square relation over here? Again, for evaluation of this cos square, I'm going to take the help of the half angle formula or multiple angle, right? So this will be 1. So cos 2x will be basically equal to 2 times of cos, yes, 2 times of cos, sorry, it's not 2 times. It will be basically cos 4x, sorry, 1 plus cos 4x by 2, and then minus 2 times of cos of 2x, right? 2 times of cos of 2x, this, then we have dx, right? So this is what we will have over here, right? Now if we just evaluate this result, so the result is going to be very simple, and the result is going to be like, so if we just evaluate the constant part, it's going to be 3 by 2, right? So it's going to be 3 by 2x minus 4 upon 2 sine of 2x plus sine upon 4x upon 4, and the limit is basically from 0 to pi by 2. So if I put in the limit and then I evaluate, so the result is going to be like, so I can take 1 upon 8, 1 upon 2 as common, and 1 upon 8 will be there. So the result is like 3 pi by 2 minus 2 times of sine pi, which is again equal to 0, and this is also going to be like sine 2 pi, which is again going to be 0. So, and for 0, all thing is going to be 0. So the result is basically equal to 3 pi by 16. So the result is going to be equal to 3 pi by 16. Okay. Now I'm going to give you the result of this right now at this present moment, but if you look at the steps of calculation over here, you will observe that there are like lot of steps involved in this particular problem. So how do we have, is there any better method to solve these kinds of question whenever we have the limits of the integral going from 0 to pi by 2? Yes, there is a method and something called as a Wallis formula. I'm going to talk about that in the coming lectures. Okay, so for that, please stay tuned for the upcoming lectures, and please subscribe to the channel and hit the bell icon to never miss any upcoming notification. Okay. So let's proceed with the further topics of the chapter, right? I hope this is clear to all of you, right? Great. Now I'm going to talk about one more interesting problem, because this is a problem that I can talk a lot. Okay, because before we understand this evaluation of integral, I didn't talk about something called as a continuity of the question, right? Or the differentiability, right? Well, I actually need to talk about that. So integral evaluation can be only done when that particular function is continuous within that particular range from a to b. Now what happens if the integral is not continuous? We're going to talk about those things also in the upcoming lectures, but for the time being, we can stick to this particular idea that it is continuous within this particular domain. And after we learn about the properties, I'm going to specifically talk about that how you can evaluate the integrals for which are not continuous in nature, right? So we're going to talk about that. Don't worry for it, right? So let us take a question based on that particular idea. So the question is very simple. It might look very simple to all of you, right? It is basically like evaluating the integral from -1 to 1 and derivative of tan inverse of 1 upon x, tan inverse of 1 upon x, right? Now why did I take this question specifically? To explain you a very interesting result. Okay, to explain you a very interesting result. Now what is that interesting result? So if you look at this functional expression over here, the interior function, that is 1 upon x over here, has a very interesting property that at x equals to 0, this particular function is not defined. At x equal to 0, 1 upon x is not defined, is not defined. Now how do we solve this kinds of question when your 1 upon x is not defined? Right? Because when we evaluate this integral from -1 to 1, there will be a point x equal to 0, which is involved in this integral limits while we are evaluating the integral, right? So that particular point where the function is not defined, how do we evaluate the integral for it, right? So I'm going to talk about it, but let's try to see how do we proceed with the solution. First of all, let us first of all differentiate the given function tan inverse of 1 upon x. Okay, so if I differentiate this tan inverse of 1 upon x, so first of all, I know by the simple properties of inverse trigonometric function, tan inverse of 1 upon x for the principal domain, it is basically equals to cot inverse of x, cot inverse of x, right? So therefore, if I just only need to differentiate cot inverse of x, which is basically -1 upon, which is basically, please don't think that there is a minus sign written over here, okay? It is basically cot inverse of x. Okay, so -1 upon 1 plus x square, that is the derivative, right? So therefore our integral is -1 to 1, -1 to 1, -1 upon 1 plus x square dx, -1 upon 1 plus x square dx, right? So if I just evaluate this, so there is a minus sign, I can take the minus out of the bracket, and this result is going to be like tan inverse of x within the limit -1 to 1, right? So if I just put in the value of tan inverse of x for -1 to 1, I'll get the result as pi by 4 minus minus of pi by 4, which is going to be plus pi by 4. So the result is going to be like minus of pi by 2. So the result is going to be equals to minus of pi by 2, right? But the careful observation in this question, if you note this question, like, so if I just give you another way to solve this question is like, you know that integration is the reverse of differentiation, right? So if I don't differentiate first and I directly write this integral result as equals to, the integral result should be equals to tan inverse of 1 upon x. What is the problem in it? And then if I put the result of this lower limit and upper limit, I'm going to get the result as, so tan inverse of pi by 1 is basically pi by 4 minus tan inverse of minus 1 is going to be minus of minus pi by 4. So the result is going to be equal to pi by 2. But this is the wrong way to solve the question. So therefore, if you just directly solve this question right over here, you will get the result as pi by 2. But this is not the correct result, because you know that when you were integrating this result, the 1 upon x function is not defined at x equal to 0. Right. So therefore, you cannot directly write the result of this solution as tan inverse of 1 upon x. Whereas you have to first differentiate this result and then integrate the rest, then integrate the given part. Okay. So because of this antiderivative is, or the primitive of derivative of tan inverse of 1 upon x in the interval is not defined. So this particular result is incorrect. So please remember this result, very interesting question. Okay. So this is a very interesting problem, and please star mark this problem. Okay. Please star mark this portion. Okay. It's a very interesting problem. Right. So I hope this is clear to all of you. Right. So I hope this question is clear to all of you. Now let's now move into another very important topic, that is the what is the geometrical interpretation of, our definite integral. Okay. But before that, let me take some questions. Cricket channel, good evening. Good evening. Okay. Let me take some questions. So please let me know your questions in the live chat. Okay, I can help you out with your any queries you are having, or else we can proceed with the rest part of the topics. Okay. Any questions? Any questions, anyone? Any questions, anyone? Please let me know. So if you don't have any question, let's go on and discuss about the geometrical interpretation of the definite integral, right? So if I talk about geometric interpretation, so if I talk about geometrical interpretation of definite integral, what do I basically mean by geometrical interpretation of definite integral? Let's see. Okay, so geometric interpretation of definite integral. Okay, so let's see the geometrical interpretation of definite integral, right? So in our earlier lectures, we have seen that what does geometrical interpretation of indefinite integrals actually mean. So they basically refer to the family of all curves, right? Similarly, over here, let's try to understand what is a geometrical interpretation of definite integral, right? So let us say if I have if I have the function, if I have the function f of x which is greater than 0 for all x belonging to the closed interval a to b. Let's say I have the function f of x which is greater than 0 for all the for the domain interval which is belonging to the closed interval a to b. Then, I have seen that our definite integral from a to b for the function f of x dx is actually equals to the algebraic area. Okay, is equals to the algebraic area under the curve from x equals to a to x equals to b with y is equal to f of x. Okay, so it is basically referring to the one of the important area that is called as algebraic area, right? Now, why there is difference in this algebraic area and simple area? Well, whenever we talk about area, we actually refer to geometric area or we refer to the magnitude of the area, right? We are never concerned about the sign of the area, right? But when we evaluate the definite integral, the definite integral result is evaluated in such a way that it always encounter for the sign, because the part of the area which is lying above the x-axis, the y coordinate are taken as positive, and the part of the area which is lying below the x-axis is the y coordinate are taken as negative, right? So when you evaluate the definite integral is as a whole from x equal to a to x equal to b, you get the area with the given sign such that the y positive and y negative is encountered for in the given problem. Okay, so I hope this is clear to all of you. So in general, this denotes the algebraic sum of the area of the figure which is bounded by the curve. Okay, so now what is basically mean by the algebraic area? If I need to discuss and elaborate about it, I will rather give a simple example. Let's say I have a given curve for the function and expression. Let's say it is starting from x equals to a and going up to x equal to b. Okay, let's say the functional interval looks like this, something like this. Okay, and some function like this, right? So when it is going from x equals to a to x equals to b, so let me denote these areas. Okay, this particular area is given as this particular area is given as a1. Okay, this particular area is given as a2. Okay, let this particular area is given as a3, and this particular area, let us say, okay, let us say this particular area is given as a4, a5, a6 and a7, right? So when we evaluate the definite integral from x equals to a to x equals to b for this function f of x, and this is the graph of the function y equals to f of x, right? So when we evaluate this integral, the definite integral, the algebraic area basically refers that you have to sum up all the areas taking into consideration the sign of that area, right? So for all the areas which is lying above the x-axis, the area will come with this positive sign. So it should be like a1 minus a2 plus a3 minus a4 plus a5 minus a6 plus a7. So as you can see, all the areas which are lying above the x-axis are taken with a positive sign, and all the area which are lying below the x-axis are taken with the negative sign. So this is what I basically referred when I mean to say that it is the sum of the algebraic area, right? Now the question arises, then if it is the sum of the all the algebraic area, how am I going to find out that when I need to find out the area bounded by the curve? So when you need to find the area bounded by the curve, you just need to put a mod over here. You just need to put a mod over here. So if you put a mod over here, that basically denotes the area bounded by the curve, right? Because that will give you the result for the magnitude of the area, right? I hope that is clear, right? So if I talk about area bounded, okay, area bounded by the curve. So whenever in our next chapter of area, whenever I talk about area bounded by the curve y is equal to f of x, you will always evaluate this result, this area, by integral from a to b and take a mod of it, okay, and take a mod of it from dx, right? I hope this is clear. So whenever we talk about area, you just need to incorporate for the magnitude of the area, okay? So I hope this result is clear, right? So this is for the area bounded by the curve, okay? But definite integral refers to the algebraic area or algebraic sum of all the areas. So this particular thing is very, very crucial and important in order to understand and solve questions as well. Okay. Is this clear to all of you? Is this question clear to all of you? Please let me know. Is this question clear? Ovilian Sol. Yeah, good evening. Yeah, great. Any questions? Please let me know if you have any questions in the live chat. Okay. I'm just going through your live chat so that I can answer your queries. If you have any queries, please let me know. If you do have any queries, please let me know. Otherwise, we can proceed with the upcoming topics, right? So let's take up some question and to practice the integral evaluation, especially for piecewise defined function. Okay, especially for piecewise defined function. Okay, So let us say I have a question. I have an integral question to evaluate from 0 to 3 x plus, sorry, let's take x minus 1 multiplied with x minus 2 and then take a mod of it. Okay, x minus 1 multiplied with x minus 2. Now I'm going to explain you how you can solve this question by using algebraic notation, or how you can solve this question by simply using graphical representation, right? So if I talk about this particular expression over here, let us first of all evaluate and see that how can I expand this result of this modulus function over here. So modulus can be given as x minus 1 into x minus 2 if I have x which is less than 1, or when your x is greater than 2, then it will be opening up in positive. But it will be negative when your x lies between 1 and 2, when your x is lying between 1 and 2, right? So therefore from here you can see if the critical points are 1 and 2, so for this will be the sign scheme for the function over here, right? So therefore when I need to evaluate the integral, when I start from x equal to 0 to 1, the result is going to be positive. From 1 to 2 the result is going to be negative, and from 2 to 3 the result is again going to be positive, sorry, right? So therefore this result of the integral can be split up into three different functions, three different limits, that is going from 0 to 1. Since why it is going from 0 to 1, it is very important to consider, because I defined that definite integral is a sum of all the algebraic areas. So if I break into small interval and I add up all the areas, I'm going to get the same result, right? So therefore let us first break the integral from 0 to 1, and in 0 to 1 the function is going to be positive. Similarly in 1 to 2, okay, similarly in 1 to 2 it's going to be negative. This is going to be negative, and from 2 to 3, and from 2 to 3 it's going to be again be positive. Okay, again be positive, right? So therefore if you evaluate this result, you will going to get the solution for this question. Okay, I leave up this evaluation up to you, because it's a very simple question. Just expand it. The result is going to be x square minus 3x and plus of 2, right? So if you just integrate and there is a result, put in the values of the limits and get in the result. Okay, so ultimately if you just solve it correctly, you'll get the result as 11 upon 6. Okay, so that is going to be the result for the definite integral, right? But there is one fancy method or fancy way of solving the same question, right? Now let us learn that fancy way of solving this question, because sometimes the modulus result will be very critical to evaluate in terms that you won't be able to understand, okay, in which interval it is positive, which interval is negative. So rather let's go with the graphical approach, right? So if I look into this function over here, because it's a quadratic expression, x square minus 3x plus 2, right? And then we have mod of it, right? So first of all, let me do some graphical interpretation of the quadratic function itself, and then we'll apply the modulus function over there, right? So let us first of all apply the graphical result for this quadratic function over here. So if I just see, the roots of this particular result are 1 and 2. So 1 and 2 is the roots, and this is going to be the upward opening parabola, right? It's going to be like upward opening parabola like this, right? I hope this method is, the graph is clear, right? So this is the graph of the function x square plus 3 minus 3x plus 2, right? This is a graph of the function x square minus 3x plus 2, right? Now if I just put a mod over here, so putting a modulus is actually referring to that the result is going to be positive. So if you look at this function over here, in between 1 to 2 the result is negative. So just by putting modulus, you don't need to do anything else. You just need to flip the graph which is below the x-axis to the above the x-axis. So therefore this particular result is going to be cancelled out, and this result is going to be flipped up over here like this, right? This is going to be flipped up over here like this, right? So ultimate result will be like from 0 to 1, and then from 2 to 3. So therefore now if you evaluate, the result is basically, we were evaluating is basically this particular area, right? So this is the graphical method to understand how we basically need to solve this definite integral, right? Now please don't use the result of the area of a triangle to solve it, because it's not a triangle, it's a parabola. Okay, but why I wanted to talk about the graphical approach, because sometimes the question will be simple linear function. Okay, so in case of linear function, you can just draw the straight lines, right? You just need to draw the straight lines like some place over here, like this kinds of functions, right? So okay, for like x, if I have x minus 3 mod of plus x minus 2, like this kind of function, so you will have different types of questions you can see in the examples as well. So then the result is like a straight line. So in that case, you can use the area of the triangle to solve the result, or the simple areas and how you can evaluate it, right? So that will be much simpler. You don't need to actually solve for the integral, right? So that's why I wanted to give you the idea for the graphical interpolation, right? So please take this in idea, and whenever you see these kinds of question, please try to apply the graphical method as well, right? I hope this is clear to all of you. I hope this question is clear to all of you. Okay, so if this question is clear to all of you, I want to give you one homework problem for all of you to practice. Okay, a homework problem. Okay, this is a homework problem for all of you. The first question is given as, you have to evaluate the integral going from 0 to pi by 2 dx upon a square cos square x, sorry, a square cos square x plus b square sine square x. Okay, you have to just evaluate this integral result. Okay, you have to just evaluate this integral result, and that is a very critical result. And please remember, sometimes in exam this kinds of question will come up, and you will be confused on how to solve this result, right? Because it's a very simple result and you can remember the result as well, right? So please try to solve this result and let me know in the upcoming class, so that I can discuss about the solution as well, right? And it's a very standard result, right? And the second question I want you to basically solve is this question. Okay, please evaluate this integral from minus 2 to plus 2 dx upon 4 plus x square, dx upon 4 plus x square. Okay, first of all, please solve this question directly by using the formula. Secondly, try to use the substitution, t is equal to 1 upon x. Try to use the substitution t is equal to 1 upon x. Please try to use the substitution over here. Okay, and tell me what is the answer. Okay, and whether the two answers are basically matching it or not. Okay, so please use the substitution over here and then try to solve this question. Okay, so the integral substitution remains the same as what was taught in the indefinite integral, right? But when you do a substitution, please don't forget to change the limits in the newer variable. Okay, so please do that needful. Okay, I hope this is clear to all of you, right? So if this question, if this part is clear, we can hi Santanu Patel, so boring. Math. Why do we need limits in integral? Well, good question. Why do we need limits in integral? Well, if I need to ask you a question, like I need to find the area bounded by very complex function, how can I get the area bound by the complex function when it is not defined at particular interval, right? So therefore, we actually have to use the concept of limit, right? And if you are asking this question, why do we need limits in integration? I hope you are a junior class students, maybe class 6 to 10, okay? Because if you have studied calculus and if you have studied limits, you won't be asking this question, right? And Santanu Patel, no one has asked you to basically watch these lectures, okay? If you feel boring, go and watch your reels, okay? That is more interesting. At least these are lectures are basically for the students who are preparing for JEE Mains and JEE Advanced for the upcoming years, okay? This is not a real platform, okay? Anyways, so with this, I will conclude my session, and please solve this question once you come for the next class, okay? I hope this is clear to all of you. I hope this is clear, right? Okay. So, and another very important news, okay, we have already started our live batches, and if you want to get 1 week paid tuition, also you can take up just at rupees 49 rupees, okay, just 49 rupees, okay, and the link is basically in the floating in the live chat as well as in the description box, okay. And also if you want to get any more information regarding how the classes are there and how you can study from the platform and how you can uh, get access to the live classes, you can contact us on this particular number. In order to get the connection from me and my team, you can contact us on this number. Okay, so please contact us on this number to get access to the live classes or paid batches. Okay, you can get access to our live classes. We've already started live classes, and the live classes are running very smoothly with lot of students. Okay, so why wait? Please join now if you want to prepare for the upcoming JEE Mains and advanced examination. And if you have a lot of backlogs and you want to finish the backlog, you can take a 1 week backlog clearing classes. So in that 1 week, you will be having like 3 to 4 classes in a week, and you will cover the backlog. And every week you just pay rupees 49, just rupees 49. So that is like tremendous small amount of fee that you are basically paying as a help to basically help us grow in this channel and also reach out to the millions. Okay, so with this we will conclude our session over here. Thank you for your attention, and